This question is from 1990 AP Physics B AP exam, and now these topics are covered in AP Physics 2. So in this question, they say that a battery with an EMF of 24 volts and an internal resistance of 1 ohm is connected to an external circuit as shown above. Determine each of the following: the equivalent resistance of the combination of the 4 ohm, 8 ohm, and 12 ohm resistors, and then the current in the 5 ohm resistor. I will redraw the circuit that is given, so it will be easier for us to see the connection of the elements. So I have the battery, then I have the internal resistance. I'm gonna call it the lowercase r, which is 1 ohm. Then I'm gonna have 5 ohm resistor. Then here is point B. Then I have, so right here is point, we can call this one point A. And this one is point C. And here is gonna be our point A. Actually, it's the same as C. So because there is no resistance on this line, then anywhere on this line, a point would be the same as C. Then I have this resistor of 12 ohm. And on the next branch, I have 2 resistors connected in series. So this one is 4 ohm, and this one is 8 ohm. And it's easier to see this way which ones are connected in series and which ones are in parallel. So what I can do is I can redraw the 4 ohm and 8 ohm resistors as one resistor, equivalent resistor for those two. Because they're connected in series, all I have to do is to add them. So 4 and 8 will give me 12. So instead of 4 and 8 ohm resistors, I can place one resistor, and the equivalent resistance of it is going to be 12 ohm. Now I see 2 resistors connected in parallel. So this resistor and this resistor, they share the same nodes, the point B and the point C. So because they share the same nodes, they share the same voltage or potential difference, and they're in parallel. When I add 2 resistors in parallel, there is a formula. So if I have 2 resistors in parallel, it would be 1 over resistance 1 plus 1 over resistance of the second one, and that will give me 1 over their total resistance. You could use this formula to do your calculations. In the classroom, we usually say it this way: 1 over, the result is over. So it's going to be 1 over the first resistor, which is 12, 1 over the second resistor, which is 12. The result is 2 over 12. So it's 1 over, your result, flip over. So what I can replace those 2 resistors is with 6 ohm. So if I erase these resistors together and place one equivalent resistor between the point BC, then I will get 1 resistor, and the circuit will not know that there are some changes happened. It doesn't affect the circuit anyhow, because this resistor is equivalent to the other 2, and so this resistor is 6 ohm. Now what's left is only 2 resistors in series. So the total resistance of this circuit is going to be 11 ohm. For the series connection, you just add them. And then for the next question, they ask you the current in the 5 ohm resistor. So they said that the battery was 24 volts, and if this is the battery, I'm gonna make some kind of fat battery. Then if I look at the total resistance of the whole circuit, not the one that is on the outside of the circuit, but including the internal resistance, then the total resistance in this case, or the sum of all resistors, including the internal resistance, is going to be 12 ohm, because the internal resistance is 12 ohm. And if we want to know the current in the circuit, I'm going to use Ohm's law. V is equal to IR. So the current in the circuit, the current flows from the positive to the negative. So the longer one is the positive, the shorter one is negative. And the current goes from positive to negative in this direction. So the current is going to be equal to the voltage of the circuit divided by the total resistance. Then I have 24 divided by 12. So the current in the circuit is 2 amps. So going back to answering the questions, they ask the equivalent resistance of the combination of 4, 8, and 12 ohm resistors. So I only had to do 12, 4, and 8 ohm resistors. So the equivalent of those we calculated was 6 ohm. And then they asked the current through to 5 ohm resistor. So that we calculated was 2 amps. And now they want you to find the terminal voltage between the point A and C. So between the point A and C, or I can also say the voltage between these 2 points, the total resistance of this whole circuit right here was 11 ohms. So if I want to calculate the voltage, the terminal voltage between A and C, then I will say that voltage between A and C is equal to the current in the circuit times the total resistance of the whole combination, which is 11. So the total resistance of all of those. So VAC is equal to the current, we calculated 2 through the circuit, times 11, and that will give me 22 volts. So this part is 22 volts. For the next question, they ask you the rate at which energy is dissipated in the 12 ohm resistor. So I have to figure out how much current is going to go through 12 ohm resistor at first. So I know that when the current is leaving the battery, there are 2 amps of the current leaving the battery. Then the potential difference from Ohm's law, V is equal to IR. The potential difference on the first resistor, the voltage, the current times the resistance, will give me 10 volts. But the total voltage that I'm to lose in the circuit supposed to be equal to 24 volts, and 10 of them I lose on the 5 ohm resistor. I will also lose some of it inside of the battery itself because I have internal resistance in there. So I will lose 2 volts over there. Again, V is equal to I times R. The current is 2 and the resistance is 1. So that gives me 2 volts. The total voltage so far on this path, either through this way or that way, through the whole circuit, the total voltage that we see being lost is 12 on these 2 resistors. So what we have left is only 12 volts to lose, because the total we have to lose is 24. So between point B and point C, we have to lose another 12 volts. So because between point B and C, there is potential difference of 12 volts, then I know that the current that is going to flow through the 12 ohm resistor, if I calculate the current, that's going to be the voltage over the resistance. The voltage between BC is 12 and the resistance is 12. So only 1 amp of the current is going to flow through a 12 ohm resistor. There were two amps altogether. That means another 1 amp is going to go through the other 2 resistors. So when they ask me to calculate the energy dissipated in the 12 ohm resistor, what they're asking me is the power. So if I want to calculate the power, I will use the formula V times I, or if I replace the V with I times R, the power is going to be equal to I squared R. Or if I replace I in this formula with V over R, then the power can be written as V squared over R. So on the AP exam, they usually give you only this formula, but you can also derive the other two by using Ohm's law. So if they ask me to find how much energy dissipated, energy is again the power because it's joules per second. So when they say the change of energy or rate of change of energy, it would be again the power. So if I'm calculating the power, since I know the current and I know the voltage, I can plug in the current between BC times the voltage between BC. So that gives me 12 watts. So the energy dissipated on a 12 ohm resistor is equal to 12, and power is measured in watts or joules per second. When they asked me for E to find the magnitude of the potential difference between BC, we found it a little bit earlier. This is when we said that the potential difference between BC is 12 volt. So we have right here 12 volts. And then for the last part, they ask you the power delivered by the battery to the external circuit. To calculate the power that is delivered to the external circuit, I can use the total resistance of this part, the one that we calculated at the beginning of the video. So we said the total resistance right here is going to be 11 ohm. And the current that is going to be flowing through the whole part over there is 2 amps. Just a few minutes ago, I said that the power can be calculated as V times I, or I squared R, or V squared over R. So because I know the current and I know the resistance, I can use this part to find the power. So the power is going to be equal to I squared, which is 2 squared, times the resistance of that green part, the one that we calculated, the total resistance is 11 ohm. So that will give me the power of 44 watts. And that is all I have for this AP FRQ question, AP Physics B FRQ question from 1990. Thank you for watching, and I hope I will see you in my future videos.